Hello, dear authors and invited guests. Welcome to technical session 4A. Good morning, good afternoon, good evening, wherever you are. It is my great pleasure to welcome you to the 5th World Conference on Smart Trends in Systems, Security and Sustainability through Zoom on behalf of WS4 2021 and Global Knowledge Research Foundation. We are thankful to everyone present on this platform to go along with us digitally for the conference in these unpredictable circumstances of COVID-19. And
sorry, Nahid, Mike, your voice is
my mic?
Yeah. Your voice is very low.
My voice is very low. Is it better now?
Yes, please continue.
Okay. And making this conference more productive. And we wish everyone and their families a protected time, and we will together pass this soon. We hope you will enjoy these 2 days of knowledgeable interactive sessions. Just before we get started, I would like to introduce you all to the session chair for this for today, and it will be Thita Pornogano-Kratana. So hopefully I didn't butcher the name.
Almost.
She received a bachelor's in science degree in media technology from the King Mongkut's University of Technology, Thonburi, Bangkok, Thailand in 2015, and the master's in engineering degree in electrical engineering from the Chulalongkorn University, Bangkok. Her research interests include computer vision and machine learning, specifically human-computer interaction for surveillance videos. She is serving as the president of the IEEE HKN Untitled Chapter. Thank you for chairing the session. And I would like to start with the papers. Also, there's a special note for the presenters. You were given 12 minutes for the presentations. On 10 minutes, I will raise a gentle reminder and a request while the presentation is going on. Other participants kindly be muted. So our first presenter is Yevgen Koku from the Sumy State University in Ukraine, and his paper title is Towards 3 Parameters Group Encryption Scheme for MST3 Crypto System Improvement.
That's right. Thank you very much. Let me share my screen and we can start our session here. Hello, dear participants, organizers and colleagues. Welcome to our conference. I'm so proud to be a speaker here, and let me try to convince you with our research and the results on post-quantum crypto system research that we have made jointly with the colleagues from different universities here in Ukraine, which is Kharkiv National University of Radio Electronics, also is Batumi Shotarovsky University of Georgia. So, and together with this research is actually founded by CRDF Global, and the part of this work is also done with the commitment of the research goals. So this paper is about post-quantum crypto system implementation. And here the main concerns and challenges for the post-quantum crypto system candidates that you can see on the table here on the slides. So let me sum up everything what we have for now. We have, of course, the results of NIST competition, and some of the crypto system which is present here are nominated for the different rounds. And here you can see that the type of such crypto systems are actually quite different, and some of the crypto systems is only the encryption schemes. Some of them allows to have encryption scheme both with key encapsulation methods. Some of them are just signature. And as you can see on the bottom, by comparison of the present schemas that already been developed and are not such as schemas are not considered as a post-quantum crypto system. So there are just a few systems which can represent both encryption, signature, and key encapsulation methods. And of course, they all compete to each other with some security constraints, speed of realization, possibility to implement different types of groups, and of course, key parameters, which has now become less critical as in 19th when the less key parameters was considered only as a possible crypto system realization for very low speed possibilities of CPUs being made in such early 90s and even to 2000s. So our motivation and pre-work that we have found the original idea of public key crypto systems based on the proposal to use the word problem in the groups and semi-groups, which is proposed by Wagner and Magyarik. So this paper was published in early 1985 and well known in cryptographic society as one of the implementation of a word problem in public key crypto system. So, and it's a lot of papers being done discussing some combinatorial group theory and implementation, and actually the impact of different design of these groups. And also Maglivers embodied this idea in crypto system based on factorization of finite group of some permutation called, it's a sum of the type of factorization which called logarithmic signature. And we also use this idea to actually try to find the solution which will be secure enough to be considered as a post-quantum cryptographic system. So we have contributed with variety of different groups and schemas already been considered with a method to find such a best security parameters which will satisfy post-quantum cryptography candidate conditions. So, and we have MST3 known results, which is shown in this slide. And this is the crypto system which is used logarithmic signature, as I have mentioned, and based on Suzuki groups, which you can see the representation in the right table in the top, with the center of the group and some multiplication operation which shows in the matrix representation. So, and some experimental results are well known and given for security parameters as well as private key, public key, encryption time, and time of decryption. So for the very first time here, we use K generation pair, and such steps are represented on the slide as well as in our paper. And as a finally, we get some public key and secret key represented and generated here. So this is the practical example on how actually such a keys will be generated here, public and private key, in the form of the matrix representation, as you can see. So this algorithm is firstly presented in a paper by Svaba, which is actually in dissertation in his PhD thesis, which called covers and logarithmic signature of finite group in cryptography. So we use the same idea to show up that we can show how the keys will be generated. So next step is the steps of encryption, and a practical example here which shown how the actually cipher text will be encrypted within the keys that we already previously generated. The decryption step is also presented in our paper with some practical example. And as you can see, the message here was also recovered. So we have also done security analysis of the proposed method. And as you can see, that it shows quite optimistic security parameters. And by comparison with other different groups that we have used, some of the parameters even higher. So and the reason of such good security parameters is that we have used their group with very large order and non-trivial center. So by the construction of logarithmic signature based public key cryptosystems, we have a lot of advantages for such cryptographic implementation, as well as to have better security parameters, and such an encryption scheme and such an approach also allows to have not just encryption scheme, but also the scheme for signatures. And here we are widely open for joint work with other researchers and team members which are interested to have some research on non-abelian group cryptography and its application, and some the researchers who would like to participate in research to find greater opportunity and greater security for the candidate for post-quantum cryptography. Here is our team, and thank you very much for this opportunity, and I will be happy to answer any questions.
Okay, so thank you very much for your presentation. And is there any questions from the audience?
If there aren't any questions from the audience, if the session shares any questions for the presenter.
Okay, so if really no questions from the audience. Okay, so I would like to ask about like what is the most challenging task in this work? Like how,
the most
yeah,
thank you very much for this the question. Is actually different challenging on such let's say methodology and algorithm by itself. First of all, the construction of logarithmic signature by itself implies and impacts on security parameters in common, right? So we have to ensure that the construction of logarithmic signature is pretty secure and provenly secure with a method to construct crypto system by itself. Second is the realization of such crypto system, which requires some techniques, for example, to bind the keys with a method to make brute force attack on crypto system much more less efficient and much more complex in the terms of to brute force the keys or ciphertext by itself, as I have presented here for security analysis. And of course, one of the biggest challenge here is to actually choose the group, because MST3 crypto system is defined to use the group with some parameters that I have mentioned. As larger order of the group we use, as better parameters we have. And here I would like to come back to our pre-work discussion. So as you can see on the bottom, we already published some different implementations of MST3 crypto system, which based on different groups, and we already made a research and like deep investigation of possible implementation for different groups with different orders and different parameters by itself. So, and as soon we are approaching the better and better conditions and better understanding on what should be done in practical implementation to really cover the topic of crypto analysis and security analysis by itself within like deep research and understanding on what should be done in terms of implementation to achieve better security parameters.
Okay, thank you so much.
Thank you.
I think it's about time, right?
Yep. So if no one else, if anyone in the audience has any more questions, please use the chat function. But thank you for your presentation, Yevgen. So we're just going to move on to the next presenter. I'm just going to share my screen once again. So our next presenter is Milan Biswas from the University of Business Technology in Bangladesh, and his paper title is BIoT blockchain-based smart agriculture with Internet of Things. So Milan, if you'd like to share your screen whenever you're ready.
I think so. Milan is not there.
No worries. We can move on to the next.
So let's move ahead with our next presentation.
No worries. We'll just move on to the next one. That's not a problem.
Okay.
So our next presenter is Michael Date from the Nuremberg campus of technology in Saudi Arabia, and his paper title is on the development of virtual labs using digital twins and a proposal of didactic optimization using design-based research. So Michael, if you'd like to share your screen whenever you're ready.
Yes, good morning. Can you hear me?
Yes,
Yes.
we can.
So can you see my screen now?
Yes, we can.
Okay. So, and now you see the presentation, and I will start immediately. Okay.
We can't see your presentation.
You cannot see?
Yeah.
Okay. I think I need another screen here. This should be the right one.
Yes, perfect.
Okay, so I just will have a look at the stopwatch, and then I welcome you to my presentation. My name is Michael Dietz, and I'm currently working as a researcher at the Nuremberg campus of technology. I will present the paper on behalf of my co-authors. My presentation has the following content. First, I will give you an introduction to some technical terms related to the topic of virtual labs using the digital twin. A description of different lab types is provided, and after that, the technical and didactic concept of a new seminar for students in mechanical engineering will be described. Next, I will present some citations of students' feedback and the planned redesign of the seminar using the design-based research method. Lab practicals pursue several goals, including a practical experience using an oscilloscope in electrical engineering, or stimulating students' interest in a subject, e.g. Real physics experiments in foundation courses. A general aim of lab practicals is to interlink theory and practice. In lab practicals, students actively investigate technical and scientific phenomena, and so experience autonomy, competence, and social embedding, factors that promote their motivation. This work is intended for readers who conduct labs and would like to improve their teaching using digital tools. Some examples of constraints of traditional labs are described in the literatures, where the authors present one approach to sharing one of the most expensive components of engineering education, the laboratory. A variety of terms are used to describe related concepts, online and remote laboratories, and many more. Online labs are described in the literature as computer applications to conduct experimentation from a remote location. The term remote lab means the access to the lab via a remote server and client application to interact with control devices and measure data for an experiment. The virtual lab, in contrast, generates data as the result of a simulated experiment. The research question of the paper is, how can learner-centered teaching methods and learning formats be improved by rethinking the digitization of lab practicals? To answer this question, the didactic and technical concept of a new seminar using the digital twin and desktop virtualization will be described first, and a method of design-based research will be presented afterwards. A new seminar for mechanical engineering students at the Nuremberg University of Applied Sciences is provided since 2019 in a hybrid format with presence and online dates. The course is called Digital Twins for Virtual Commissioning of Production Machines and is for undergraduates of mechanical engineering. The digital twin is described in the literature as a digital replica of a living or non-living physical entity. A 3D printer is a descriptive example for students to learn about important topics like behavior modeling, visualization, and simplification. The limits of feasibility can be explained by excluding the real printing process of filament and the execution of G-code in the 3D printer microcontroller. Students are taught to set up the special software configuration and create virtual models. The primary effort for the digital twin lies in the manual creation of the virtual model for each mechatronic component. Some important properties of the digital twin are shown in the slide. Next, I will explain important parts of the technical concept used for the seminar. Students are used to connect to the university network using a secure network connection to sign up for exams, etc. In the seminar, they can connect and work on the digital twin projects from their homes, following a simple step-by-step procedure shown in the slide. In the context of this paper, the concept of digitization comprises two main stages. In the first stage, real laboratory test rigs no longer exists, only a lab model in a special simulation software. This is the digital twin of the lab test rig. The overall concept will be illustrated with the help of a shell model. We will start with the most inner shell. The inner part of the shell architecture model is the digital twin. It can be realized with different software. The seminar uses the displayed software at our institution. Another shell for PLC programming is necessary in the virtual laboratory, and in addition, generic shells can be used to access specialized applications. Up to this step, the concept resembles a common configuration of a PC in a real lab. The second main stage is much more complex. The second stage involves lifting the complete lab PC into virtuality, a so-called virtual desktop or virtual machine. The complete operating system with all software applications becomes a simple program window, a PC within a PC. The installation and configuration process is similar to that of real hardware. One comment on this. Please do not confuse the term virtual machine with the meaning of the digital twin. The term virtual machine is a common term in computer science that should not be confused with the meaning of the digital twin as a virtual production machine. The virtual lab shell is the most outer shell, and it can be duplicated indefinitely as it is only a digital data image, which means it can be copied for many students. Certain limitations, such as number of software licenses, memory and storage space restrictions, must be observed. The virtualization approach described was presented earlier as a proof of concept and has since been extensively tested and is under further development. Next, I will explain parts of the current didactic concept, problem-based learning. Avoiding danger is the best feature of the digital twin. There's no possibility of hurting yourself when working on it, as it is a simulation on the computer. Through this, students are naturally invited to experiment with the virtual model because the worst outcome is that the operating system crashes and a restart is necessary. Interactivity is very helpful when a self-guided learning method is desired and helps motivate students to explore for themselves. Using a blended learning approach, the seminar combines a practical component offering opportunities to interact with the digital twin in online experiments and a theory component featuring traditional teaching methods. The problem-based learning approach includes various methodical approaches which aim at practice-based training with the target on the transfer from theory to practice through specific learning tasks called problems. The problems to solve are currently based on real-world problems in automation engineering, like finding software errors or apply optimal parameter settings. It is required for the students to formulate the problem on their own, find their own solution to deal with the problem, recognize accurate answers for the problem, and assign the needed tools in a self-controlled manner during the solution process. Similarly, the teacher's role changes. The teacher is not a speaker who leads through the lecture. The teacher becomes a coach and mediator, advising and supporting students as needed, rather than presenting each step of the solution pathway. An anonymous feedback questionnaire was provided online to receive feedback from the students. Additional students could comment on what they liked about the course, what they missed, and what may be improved. Some examples from the students' feedback is given on the slide. After this first feedback, some actions and changes were applied to the course, which are displayed on the slide here. Now I will come to the second main part of the paper, and so I will describe the main aspects of the so-called design-based research method. A need for future evaluations and further optimization of the seminar, design-based research method will be applied. A need for action to change certain aspects leads to the first phase, the analysis. In the design-based research methods, hypotheses emerge from the first phase of analysis. These hypotheses are achieved through design of interventions. Subsequently, the effectiveness of the redesign is tested and determined through another analysis by evaluation. Finally, these results serve as source for the definition of new hypotheses in the next iteration. By performing iterations sequentially, in which the hypothesis of iteration n+1 are derived from the hypothesis of iteration n, the effects of confounding variables are gradually minimized, since a single design-based research iteration would not lead to definitive representative conclusions. So mapping these general topics to our seminar is done in the following way. First, the theory-based development of hypothesis is done. The second step is to develop an optimized concept by defining common learning goals and compare the old learning goals with the new learning goals, which were developed together with external experts, shown on the previous slide. The third step is to assess the extent of the optimization and apply different features of the redesign, like learning, climate, and systemic characteristic. The final step is for a complete cycle is to rate the success and document key factors and weak points of the optimized concept. And with this slide, I will conclude my presentation, and thank you very much for your attention.
Okay, so thank you so much for your presentation. It's a very interesting work here. And is there any questions from the audience? Maybe a short one, because we are running out of time.
Okay, so if no question, I will stop my presentation.
Okay, thank you so much. Yeah.
You're welcome.
If the session chair hasn't got any questions for the presenter, I think we'll just move on. Thank you
Do we
for your
still
presentation.
have time for the question?
No, we don't have time. So let's
Yeah.
move ahead with our next presentation.
No worries. Thank you for your presentation, Michael. So I'm just going to move on to the next presentation. So I'll just share my screen really quickly. So our next presenter is Milan Biswas from the University of Business and Technology in Bangladesh, and his paper title is BioT Blockchain-Based Smart Agriculture with the Internet of Things. So Milan, if you're ready to share your screen.
Yes. Can you see my screen?
Yes, we can.
Thank you very much for giving me the floor. So here I'm presenting my paper. My paper ID is 41. The title is BIoT, Blockchain-Based Smart Agriculture with Internet of Things. So we will discuss introduction, motivation, and our proposed work, and then conclusion here. $1 with over 1 billion people living in it. Agriculture is becoming more important to countries other than the industries. Mainly the enterprises have already started to take steps in the direction as the market is on the rise. Now is the moment to reap up the benefits of information technology into the agricultural area. Despite the media can have us to think blockchain has a broad range of applications outside cryptocurrency. So we think it is a good technology that can be involved with IoT and which can help agricultural sector in a good way that will be beneficial for both the customers and the producers also, like farmers. So in that case, agriculture is a little studied industry that blockchain might completely transform. More importantly, it has a slew of issues that need to be addressed right away. With the use of information technology, we expect the agriculture sector can become more secure, transparent, trustworthy, and constructive. So here comes our motivation: inability to evaluate product quality, lack of communications between producer and distributors, lack of accessing technology at the end of level of users of supply chain. Third party can alter data that distract customer satisfactions. So based on this motivation, we develop our blockchain-based IoT technology to to make the agriculture supply chain management or agriculture more easier and useful for both parties. The proposed work model combines AI, IoT, and blockchain to develop a smart and futuristic agriculture system that provides farmers with a secure and open transaction approach to reach new active decision support that can especially create the scope of greater agriculture process productivity and help farmers maximize their benefits. So this is our blockchain-based agriculture's diagram, where the temperatures, weather data, and water supply that can be monitored with IoT. And here is the retail marketing solution that is bill, tax, and other compliances. And in the center, you can see the type of data collected at the stage where the quality control data, transportation data, food safety data, all are getting together in a data processing system. And with blockchain, we can ensure the land uses, crop efficiency, financial audit, and flood mitigation also. So I will discuss it part by part. The system model of blockchain agriculture. We have 5 main parts. IoT-based model to monitor agriculture field, crop and food production, food supply chain, controlling weather crisis, and managing agriculture finance. This is our sample setup, mini setup. I think it can be called as demo setup for our agriculture field, especially the IoT-based development features. So the first point is crop and food production. In this section, there are 4 steps: IoT devices generated data, and then cleaning the enrichment of the collected data, and then making the data more insightful with machine learning algorithms. And in the last step, data gets saved on the blockchain. So in this process, with the help of IoT devices, all the data are collected, then cleaned, then using the machine learning, we can predict, or we can develop a system that can be useful for crop and food production. Actually, the next step is food supply chain. The supply chain management is very important for this type of productive work or any type of productions. So in food supply chain, there are also 4 steps: as IoT sensors generating data from or farmers storing data, then the distribution of grown-up crops to the food processing companies. Step 3, supply of processed food to wholesaler and retailers. Consumers can, and step 4, consumers can backtrack the supply chain. So in this way, a consumer can backtrack and can be assured that the where the crops come from, the exact date, the production date, and the details they need to know in the process. So we can say that purchaser backtrack the chain from the data about the starting point of the homestead to information on transport, cluster number, food preparing, or crops preparing, and production lines. And they can investigate everything with if the blockchain system is implemented, and it is very transparent process. Controlling weather crisis. Though we all know that the weather is something that God's creations, but we can manage, we can control some criteria of the weathers. In that case, we have kept 3 steps in the weather controlling crisis. Agriculture weather stations sending essential information to the blockchain. That is, we can collect information from the weather forecast department, or using some kind of sensors, and then the blockchain can store all of them. farmers can take preventive action using our machine learning decision support system. Farmers will be notified, and then he can take the preventive actions and quick applications for the crop insurance. This step 3 is not available for all the countries, especially talking about my countries. In my country, there is no crop insurance, but it have to be done because they are investing their money, but some weather problem, they can be destroyed and their investment can be ruined. Managing agricultural finance. In the financing sector, the stakeholders plays a vital role. Those stakeholders share information at every steps of food productions. Step 2, auditors can effectively conduct audits because the steps are transparent, so there is no third-party involvement and anything. Step 3, improved quality control and food safety. Step 4, increased efficiency for farmers. Step 5, fairer payments for farmers. The last point is a key point and the motivational point for our project, because in our country, or mainly in South Asian countries, the farmers grow crops and they work very hard, but did not get the right prices of their work. So if we integrate the blockchain based supply chain or blockchain based a transparency system, then they can get the actual amount they work for. This is the bidding platform. In our system, there is a bidding platform for buy and sell crops from one hand to another hand. It can be a farmers to middleman, a middleman to brokers or retailers, anything. And lastly, the conclusions. It is under. We have proposed a safe and straightforward, transparent solution in which farmers would sell their crops to middlemen, agent, or farms in the quickest and most efficient manner possible, with no inconvenience or risk of fraud. We have the vision, we have the opportunity, we have the information technology, we have the human resource. We will not let any farmers weep by using the full potential of information technology, and we have AI, IoT, and blockchain at our disposal. So I think the proposed system is already in the production. We are developing our algorithms, and we already implement this system in a small area. But I think when the work is fully done, completed all the parts, then it can be useful for the farmers and for the retailers also, and it can be beneficial for the farmers, especially for their correct prices, and they can get the exact prices for their hard work. Thank you very much.
Okay, thank you very much for your presentation. I have some questions. First, I would like to know, like, where did you get the data?
I have get the data from our agricultural department in Bangladesh.
Also, you collect the data yourself?
The data of our data, the yearly data are available in the ministry website. I got this data from the websites.
Okay, so it's publicly available data set, right? Okay.
Yes, yeah, publicly available data set.
Okay, and I wonder about the algorithm in the part of machine learning that you mentioned. Like, what algorithm that you use and in which function? Like, you have like 5, right?
Yeah.
Yeah. Which algorithm that you use? Yeah.
Yes. We have still now we have completed two parts actually. One is food and crop productions. In that part, we implement an algorithm, and another is food supply chain. In these two parts, we have implemented two algorithms, machine learning based algorithms that can help in these two sections.
Okay, two sections. So,
Yes.
so did you use LSTM to predict this one?
We still now we implemented two different algorithms. One is LSTM, yes, and one is SVM for clustering the data and all. And we use LSTM for the predictions, but it is not actually fully appropriate or fully corrected yet. But I think we can complete it within a few more days or a few more. We need some times actually.
Okay, I think it would be better if you show like some results, maybe you can plot a graph or maybe show some accuracy here, so we can see more about the results. Yeah, but
yes.
anyway, it's a very good work. Yeah.
Okay, thank you.
And what's your plan for the future?
Our plan is a build a total system that may call field to fork a total system that where a consumer or a customer can see the product he buy and the history of this product. And in the bidding area, you have seen the bidding platform. We have kept this one because I just told you a scenario that a farmers plant something, he work hard in his field or farm and grow something, and then suddenly on or some weather hazard, the crop is all lost. So his investment is totally lost for himself, but he invested that much of money not only for himself, for also for the other peoples. So the bidding platform we are trying to build a bidding platform where the bidders ask and bid about the future crops in advance to the farmers, so that they can invest also with the farmers.
Okay, thank you so much. Yeah.
Thank you, Milan,
Okay,
for your presentation. So we're just going to move on to the next presentation. So our next presentation is by Mariam Ibrahim from the Jordanian University, but it will be presented by her co-author Ruba El Hafiz, and their paper title is Security and Analysis of Integrated Clinical Environment Using Attack Graph. So if you'd like to present whenever you're ready, Ruba.
Hello, everyone. Just give me a second so I can share my screen, please. 1 second, please. I'm sorry, 1 second. I have a problem with sharing my screen. Just a second, please. Okay, can you see my screen now?
Yes, we can.
Okay, I'm sorry for that. 1 second. Okay. So hello, everyone. My name is Ruba Hafiz, and I am here to present our paper with the title of Security Analysis of Integrated Clinical Environment Using Attack Graph. This paper was written by Dr. Mariam Ibrahim.
Oh, I cannot see your presentation.
You can't see it. Okay, this 1 second, please. Okay, why is that? I'm sorry, 1 second, please.
We can see only your blank screen.
Okay, I guess. I'm sorry. What about now?
Okay, so now, yeah.
Perfect.
Okay, cool. So my name is Rubal Hafiz, and I'm here to present our paper, Security Analysis of Integrated Clinical Environment using Attack Graph. This paper was written by Dr. Mariam Ibrahim, Engineer Haneen Okasha, and myself. My presentation will be divided into the following topics. At the beginning, I will be describing interoperable medical devices, following by attack modeling, and then I will discuss our methodology, results, and conclusions. So at the beginning, interoperable medical devices are defined as therapeutic cyber-physical system, which provide effective personal care by regulation patient-board medical devices in a clinically substantial aspects. IMDs have the possibility to impact the clinical environment by decreasing the false alarms and checking the real-time treatment interconnectivity. One of the interoperable medical devices is integrated clinical environment. Is among major significant schemes for IMDs that is established by the American Society for Testing and Materials, ASTM, also supported by the American Society for Anesthesiology, ASA. OpenICE. The medical device Plug and Play has developed the open source ICE, OpenICE, which is spread out software platform for carrying the mutual connection of network points like electronic medical record system, medical devices, decision assistant system, and sensors, and its synchronized security and performance of the tools for ICE. The risk association with medical devices has been a matter of concern for many researchers. Being equipped with wireless communication and becoming more and more popular, making them major target for attackers. Today, an attack graph representing how an attacker can compromise the ICE system will be represented. An attack graph is defined as a conceptual diagram that is utilized to analyze how to attack target. It is a standard way used to establish a tool for adequate defense. By analyzing the network and finding its vulnerability, the essential goal of an attack graph is to locate the route initiated by attacker to the target's network. It can assist determining any probable threats on the network. In order to present this attack, a graph, the ICE system firstly will be discussed. The system was identified, followed by the threat and vulnerabilities. Then the formal description was made. Then the AEDL simulation was used in order to find the possible attack routes. And finally, the visualization of the attack scenarios, which is the attack graph. IC architecture. IC consists of caregiver, which is, we will represent it with the letter C. Caregiver is in charge of configuring the system, choosing a global application on the supervisor. This application can be utilized to control almost everything, from a simple script that organizes the device action to more significant algorithm that obtain psychological parameters from sensor waveforms. The caregiver also monitors the sick people's well-being via a monitor offered by the supervisor. Supervisor, S. It is a platform where medical applications operate and provide clinical decision conforming to the data obtained from the medical apparatus. Hospital Information System, HIS. It is an integrated information system designed to manage administrative processes, patient care processes, and financing. It sustains recording of all patient services and medication, as well as billing and coupling to the Social Security institution. Data Logger, DL. It keeps logs for digital forensic inspection. It is small, portable, battery board, and supplied with an internal memory for data storage. It has also microprocessor and sensors. It allows smooth 24/7 location-independent monitoring of relevant vital sign parameters in ambulatory subjects, in hospital, and in home care. Medical devices. They are placed on or around a patient through interfaces to facilitate their networking efficiency. thus providing monitoring and actuation functionalities such as radiation therapy devices, implemented devices, and infusion pumps. Finally, network controller and supervisor constitute the ICE manager, which is IM. Those devices are shown in this image linked to the attacker access point, considering that the attacker is located at the shown spot, which can be which he or she can attack firstly the caregiver or supervisor. You can see here as well that the caregiver is connected directly to the supervisor, which is connected to the network controller, ultimately connected to the medical devices around the patient. The network controller also is connected to the data logger and to the HIS system. The attacker goal for attacking the ICE can be either to jeopardize the patient health and life or to collect confidential medical data. There are vulnerabilities within the ICE that the attacker can use, for example, firmware update vulnerability, which is resulted from the fault of the authorization of the origin of firmware upgrade. Secondly, the electromagnetic vulnerability, EMV. Electromagnetic wave carries digital data, and as such, it is vulnerable to interfaces from other electromagnetic wave. Threats or attacks that can be executed against the ICE systems are, firstly, spoofing, SP. The attacker uses a false identity to enter the ICE. After effectively obtaining the access as a legitimate host, the attacker can promote or misuse his or her authority to jeopardize the system. Secondly, denial of service, DOS. This attacks targets the network, but also interrupts the medical devices or supervisor to prohibit productive interpretation. For example, the motor of infusion pump can be burned out by the attacker through overuse, stopping it from achieving its necessary curative services. DOS attack can also be used against implant devices to deplete their batteries. Thirdly, buffer overflow, BOF. The attacker conducts memory exploitation action to overflow a buffer that causes the adjustment of an address to redirect to a suspicious script. This attack can be performed on the network controller to gain substantial control over it. The next attack is Trojan horse, TH. In this attack, a program shows up as a beneficial and safe, but once the victim install it in their computer, it starts to perform malicious actions, such as disclosing information from victim's computer. Apart from that, the victim's computer can be operated remotely, and it can be used against the ICE supervisor. Finally, intelligent gathering, IG. The use of this attack is to collect data, for example, personal information, medical data, and the type of application installed on the supervisor. Formal description. The formal description captures the architectural designations of the ICE, its parts and connections, the system behavior, its state variable, pre and post condition of each attack, and the security properties. First, we have the static variables, such as the system connectivity N, which shows the connectivity between the subsystems or the parts devices within the ICE. Secondly, the vulnerability, which are EMV and firmware. Secondly, we have the dynamic variables, which are attack level of authority Y, which can be 0 or 1. It depends if the attacker has an authority over the host device I. Secondly, we have the system information K, which is equal to 1 if the attacker collects any information. Lastly, hardware manipulation H, which will be 1 if the attacker can stop or change the functionality of the device. Here we can see the pre and post condition for each attack. For example, we have the spoofing, SP, we need to have a connection between the device, between I and J, which is the host, and the target device, and we need to have authority over the host. And the post condition for this attack is to have authority over J, which is the target device, and also to collect some information or to collect some data. Secondly, we have the denial of service. We need to have connectivity and to have authority over the host. And in this attack, we need to have one of those vulnerability, which is EMV or firmware. The post condition for this attack is to have authority over the target device and to be able to manipulate the hardware and to change its functionality. We then have buffer overflow. We also have to have connectivity and authority over the host, and it will give us the post condition, which is the authority over the target. We have the Trojan horse. We should have also connectivity, authority, and we should to have knowledge over the IM, which is the manager devices, and the post is to have authority over the target. Finally, we have intelligent gathering. We have to have the precondition is to have connectivity and to have authority over the host, and from this attack we can have more information about the system. Also, we have the initial state, which is at the beginning, the attacker has authority on the access point, no authority on ICE components, no confidential data revealing, and no capability to amend the configuration of the ICE element. Security priorities, the attacker cannot disturb the system. For example, cannot control the medical devices nor interrupt their functionality. JK coined model checker and architecture analysis and design language were used to generate counterexample, which demonstrate a collection of attacks known as attack scenario. Here you can see the first counterexample presented in an Excel spreadsheet. The counterexample attack scenario can be recapped as follows. At the beginning, the attacker had authority on the access point. An SPAPC attack is executed to spoof the caregiver device. The attacker gains the caregiver authentication credential and authority over the caregiver device. Then IGCS attack, which is the intelligent gathering attack, will be executed from the caregiver to the supervisor in order to collect to gain knowledge about the supervisor, for example, the type of application installed on it and the firmware updates. Next, Trojan horse THTS attack will be performed from the caregiver to the supervisor in order to install malicious application to the supervisor platform and gain authority over it. Afterward, the attacker executes a buffer overflow between the supervisor and the network controller to gain the authority of the network controller. Using this authority, a DOS NCMD attack is operated profiting from the EMF vulnerability in the medical devices to destroy the medical devices or deplete their batteries, endangering the patient's health. There were 6 counterexamples found. Those counterexamples are presented in the shown attack graph, which was visualized using Gravi's program and dot language. The graph has errors and nodes. Each error carries the name of the attack, the current position of the attacker, and the item that is being attacked. The final node represents ICE state where the security property is violated. As can be noticed from the graph, the DOS attack instance appeared in all the scenarios, and it can massively affect the medical device as a result of the EMV vulnerability. It also can be noticed that the supervisor can be victimized using the Trojan horse attack by installing a malicious application on it. Finally, in this work, J-kind model was used to generate all the possible attack scenarios, and then the attack graph for ICE is presented using dot language within the Gravis software. The modeling technique is based on using an architectural description language to seize the security-related features of ICE system. This research has been conducted to study the architecture, connection, and vulnerability of the ICE system in order to identify some of the cyber attacks that might be executed against it and predict their impact. The importance of creating safer IMDE system is highlighted, taking into consideration that any penetration can lead to harming the patient, stealing medical data, and altering the system workflow. Finally, thank you so much for listening, and if anyone have any question, I'll be happy to answer it.
If anyone has any questions or not, if the session shares any questions. Not, we can move on to our next presentation. Thank you, Rebo, very much for your presentation, and we'll just move on to our next one.
Thank
is it okay if you just,
Thank you so much.
That's
Yeah.
perfect.
Thank you.
So our next presenter is Rechko Victoria from Taras Shevchenko National University of Kiev in Ukraine, and her paper title is An Intelligent Model to Assess Information Systems Security Level.
Hello,
So,
everybody.
whenever you're ready, Rechko.
Yeah, sure. I'll share my screen then. Sorry, wrong, wrong display. Okay, should be. Huh? Okay, I'll try one more time. That's, sorry, can't share my screen. I hope you can see my presentation right now. Can you see slides now?
Yes.
Okay, so sorry for the delay. Hello, everybody. Thank you for coming to my talk today. My name is Victoria Hrechko, and this presentation focuses on the issue of assessing information system security level. And on behalf of all authors, I will present our findings on developing a model for classifying security maturity levels according to the controls and practices present in ISO 27001 and ISO 27002. Information security management is an integral part of the management of any organization, regardless of its scope, location, etc. However, assessing security is a difficult task, and it should correspond to the level of organizational and technological development of this company. I'd like to draw your attention on ISO 27001. This is one of the most popular information security standards in the world. More and more companies are achieving this standard certification of these standards to underline the robustness of their information security management. Although it contains guidelines for the establishment of information security management system in the company, it does not tell us what level should aim companies of different sizes to achieve a certain level of security they need. This brings us to an open question: how to meet these requirements and to what extent? As you know, a maturity level is used to characterize and formalize a state of certain capabilities using a predefined set of criteria associated with a particular maturity level, internal requirements of organization, and regulatory documents such as standards and law. Shortly, maturity models provide a set of structured levels that describes how the behaviors, practices, and processes of an organization can reliably and sustainably produce the desired results. The maturity model can be used as a benchmark for capabilities comparison as well. So we'd like to introduce an original approach to assess the security of information system that is based on information security management system maturity models. To develop a model, 6 steps were taken. Let me go through each of them with you. Firstly, I'm going to share our findings on the most popular security capability maturity models comparison. Secondly, I'll move on to the model design. I'll start by introducing the basic paradigm of the evaluation model that was created. Then I'll present the data preprocessing algorithm and how I use it to collect and preprocess an input data. And finally, I will explain you how the model entities and learning was performed. And I'll finish with the model evaluation results, of course. A number of recent studies have shown that a large set of information security maturity assessment models based on similar principles, and they are available for both commercial and governmental organizations and institutions. At the same time, the actual use of such models is quite limited, primarily due to the weak link to the characteristic of specific organizations. And the most popular models that could be used to assess the information security could be found in the table. You can see some basic information about these models as well. And according to the findings, all models have in common focus on continuous improvement in delivery of results. They have a small number of defined levels, usually it's 5 levels, and have some similar processes. Some authors have driven the further development to covering the ISO 27001 requirements. And for example, it was reported in the literature that a small set of maturity models could be used to determine compliance with this standard. The table here shows this level of coverage, and the number in column is simply represents the number of coverage requirements in corresponding section of the standard. The main conclusion that can be drawn is that there's no maturity model that would satisfactorily meet the requirements of the ISO 27001. Aforementioned findings provide a potential mechanism for the generic paradigm of evaluation model. This slide shows mapping between generalized requirements to an information security management system at a certain level of maturity. Ideation is exciting, but without putting the idea through its paces, we can't answer if the idea is practical, feasible, if specialists will actually want to use it, and what resources required. This and other questions will be explained in the next sections of our talk. Recovery from a cybersecurity incident can be a daunting undertaking, especially if you're lost critical information. Every second of downtime is costly, but you can limit the damage to your company and your reputation using some special systems and tools. Speaking of tools, these security systems and tools must continuously adapt to evolving conditions, threats, and bad actors' approaches to provide a resilient and continuous defense. I'd like to emphasize that the peculiarities of this problem are the complexity of its criminalization, also the presence of uncertainties associated with incomplete data, and the presence of significant numbers of interrelated, not only quantitative, but also qualitative indicators, right? Also, once data volume grows and becomes very diverse, the amount of time and money required to determine compliance with existing regulatory standards and policies rises, as well as the number of possible inaccuracies, measurement errors, misinterpretations, etc. An alternative method to traditional algorithm methods and models of decision-making and management is using intelligent technologies. Artificial neural networks are used for modeling nonlinear problems and to predict the output values for given input parameters from their training values, which can help to solve numerous limitations in today's cybersecurity tools due to their scalability and adaptability. For the aforementioned reasons, it was considered to build a maturity assessment model on the base of ENN. I'll tell you more details in one of the next sections. So, next step will be the development of data preprocessing algorithm to create the input for the model. You can see the algorithm now. And I'd like to continue with the data collection. Data sets are typically a collection of the data records with a variety of properties and related details that originates from the data model. Right. Firstly, we collected some data about the information security management system. For this purpose, we employed survey data collected from a special questionnaire that keeps in mind all the domains and controls of ISO 27001 Appendix A. The data includes a set of estimates based on the corresponding control description available in ISO 27002. It was decided to use this standard in particular because it contains a more complete description and recommendations for the implementation of information security controls. However, the real data couldn't be used with respect to confidentiality and ethics. Thus, the input data was generated randomly. Secondly, the data was labeled with corresponding maturity level to allow model to learn. And data instance consists now of two parts: security control estimate set and a class associated with it. The table shows the table at the top of the slide shows a sample of the questionnaire used to perform the data collection, and the table in the bottom of the slide shows the maturity mapping rule. Here you can see 5 possible values of the attribute, which scales from 0 to 5, with 5 being the highest level of maturity. The input data now consists of 10,831 instances. A graphical representations of the frequency distribution of data instances in the training data set by the associated class is shown here. Here you can also see some procedures that were taken to improve the quality of the input data. And finally, we'll talk about model synthesis and learning. For the aforementioned reasons, it was considered to build a maturity assessment model on a base of ANN, feed-forward and artificial neural network with backpropagation in particular. The proposed model consists of 3 layers of nodes: an input layer, a hidden layer, and an output layer. You can see a generic scheme. You can see figure 1. It illustrates the generic scheme of this model. But a maturity model can be assumed as structured collections of items that detail the features of effective processes or products. Then the number of nodes in the input level equals to the number of controls in ISO 27001, and the input layer in the input for each node is an estimated value for a particular security control, respectively. The output layer of the model includes 6 nodes that represent maturity level according to the ISO 21827 standard. The number of hidden layer neurons was determined as an arithmetic mean between the number of nodes in the input and output layers, and equals to 60. Okay. And to verify the accuracy of the model, the original set was divided into smaller parts and evaluated using by 2 different methods. First, a cross-checking method was performed to identify model performance statistics. Then the model was retrained by using a 100% data set to give the most accurate model to obtain the most reliable classification model. The learning outcomes of the model are presented below. These values indicate that the trained model describes a real non-automated process of assessing the maturity of information security management system at an acceptable level, and it can be recommended to use in the process of real audit of information security management system. This also means reducing the amount of time and finances spent on security assessments by businesses. As a part of future research, the data set should be adjusted to achieve better results in future studies. The data set wasn't balanced well, but the approaches described can be also extended to synthesize a model for different security control set and consequently to verify compliance with another security standard or policy due to the ANN approach that was chosen because of its adaptability and versatility. Okay, we are coming to the end of our presentation, so I'd just like to thank you for listening. I hope you found it interesting.
Okay, thank you so much for your presentation. Very nice presentation. I just have one quick question. What is your time complexity here?
You mean how much time I spent to train this model, right?
Yes.
So the time required to I remember it was
for testing.
Training time was 50. I used 50 training epochs to train this model. I can't remember the exact amount of seconds, but if you message me later, I can find the logs.
Yes. How about testing? Like the time for testing? testing?
The time for testing was like, wait a minute, I have some notes. Oh yeah, the time required to test the model on the training data set was 12 seconds.
12 seconds, okay.
Mm-hmm. I didn't use a really big amount of epochs to train this model because we wanted to perform a proof of concept and something like a minimum value product at first to test how is this model could be used, if it's useful at all, and what the results and outcome. So yeah. Of course, as a part of future research, it should be trained with a bigger amount of epochs to achieve more, a bigger level of accuracy, of course.
Yeah. So that would be your future work, right?
Right.
Okay, thank you so much. Yeah.
Thank you.
Thank you for your presentation. So we're just going to move on to our next presenter. So I'm just going to share my screen. So our next presenter is Kamlesh Kumawat from IIS, deemed to be University in India, and the paper title is ICT Enabled Automatic Vehicle Theft Detection System at Toll Plaza. So whenever you're ready to share your screen.
Hello. So is this visible?
Yes.
We can see your screen.
Okay. Just a second, please. Okay, namaskar everyone. My name is Kamlesh Kumawat and I'm a research scholar at IIS University, India. This is the first time I attempted to write a technical paper under the guidance of my supervisor, Dr. Vijay Rathore, sir. So thank you, sir, for your guidance. And also thank you, Words for You, and the organizers for giving me the opportunity to present the paper. I'm glad to be here. I'm glad to be here. Let's get started. Okay, so the topic is ICT-enabled vehicle theft detection system at toll plazas. The outline of the research is introduction, then vehicle theft statistics in India, role of electronic toll collection system in detection of theft vehicles, literature review with the limitations of existing system, methodology, elements of the same, working mechanism of the proposed system, and results with conclusion and future scope. So according to the articles published by some newspapers in India, shows that vehicle theft detection is the least solving cases by police department in India, and the recovery rate of the same is too low. So the paper, the objective of this paper is to vehicle theft statistics in India with theft vehicle recovery process, also role of electronic toll collection system, and the limitation of this existing system will be also described, and the system will be proposed to overcome these limitations. So according to the article published by Times of India in year 2018, shows that only 13% of stolen vehicle recovered at Mahali in India. Another article shows that 5 vehicles per hour were reported theft in Delhi. The article shows by the Hindu in year 2019 shows that only 19.6 cases solved of vehicle theft in India. And during lockdown, during COVID pandemic, the cases increased at Mumbai in year 2020, shows according to the report Indian Express, and the detection rate also dropped to 39%. The chart shows by Hindustan Times in year 2020 shows that motor vehicle cases are continuously increasing year by year. So what is the role of electronic toll collection system in detection of theft vehicle? Whenever RFID mounted tag vehicle arrived at the toll plaza, whenever a vehicle, first of all, whenever a vehicle theft, the owner of the vehicle lodge FIR to the police station. The police station then informed the RTO, Regional Transport Office, about the vehicle, and the RTO blacklisted the tag which is mounted on the vehicle windshield. Whenever a vehicle reaches at the toll plaza, the RFID reader read the tag and it is shows as blacklisted, then the system automatically inform the police station and the owner of the vehicle, and the authority do not allow the vehicle to cross the gate. So this is the basic ATC working in detection of theft vehicle. There are some other situation may occur whenever a vehicle arrived at the toll plaza and it is not theft, then the system automatically deduct the toll amount and they allow the vehicle to cross the gate. Another situation which is going on is whenever a vehicle have no RFID tag, then the system, the authority collects double cash amount and then they allow the vehicle to cross the gates. So I have gone through lots of papers and some of the papers are here. According to the year 2015, a system introduced which is QR code. The QR code technology is working as same as RFID, but QR codes are not sustainable in harsh environment because we mount the tag on the windshield of the vehicle, so they are less sustainable in comparison of RFID tags. And also QR codes can be copied. So another technology introduced in 2016 is OTP. Whenever a vehicle suspected as theft vehicle, the authority asks a unique code to the owner of the vehicle or the driver, and if the code is valid, then only they allow the vehicle to cross the gates. The technologies introduced in the combination into year 2016 was GPS, RFID, fingerprint identification system, and a smart card. The GPS locate the real-time location of the vehicle, and RFID, as I discussed before, work. And the fingerprint identification system is useful to identify the driver and whether the driver having license or not. And a smart card is only used like a debit card. After showing the smart card, which is RFID card, then only the amount deducts from the owner's account, and then only the system and the authority allow the vehicle to pass the gate. The technology introduced in year 2018 shows the RFID tag. The RFID tag mounted vehicle arrived at the toll plaza, and if it is not blacklisted, then the amount deducts from the owner's account, and an acknowledgement message sent to the owner's mobile number, and they allow the vehicle to cross the gate. And if the tag is blacklisted, the secret message sent to the police station and the vehicle owner, and they do not allow the vehicle to cross the gate. The technology introduced in 2019 was RFID card. As I discussed before, that the driver have to show the card. After that, the amount deducts from the card, and then only they allow this vehicle to cross the gate. The fingerprint and driver identification system, the vehicle, if the vehicle is theft, the owner identified by the proposed system. Another technology was number plate identification and immobilization. In this technology, when a camera captures the image of number plate of the vehicle, and if everything is okay, the amount deducts from the owner's account and the gate open. But if the vehicle is theft, then also the amount deducts from the owner's account and the gates open. But after a few seconds, the system immobilizes the vehicles. The technology introduced in year 2021 is ANPR, which is automatic number plate recognition system. According to this, the camera captures the image of number plate of the system of the vehicle, and if it is theft, the system automatically sends a message to nearby police station and the owner's registered contact number, and the gate remains closed. So these are some technologies currently working for detection is theft vehicle. The limitations of these technologies are there is no existing model from which we can detect the vehicle in the following situation. Like if a vehicle is theft and it is reported or non-reported at the police station, and if the vehicle has RFID tag or not, or with fake number plate or original number plate. There may be some situations, some situation may occur, and there is no such model to detect this, the vehicle in these situations. Also, there is no application already introduced from which we can get the overall status of the vehicle. Like if the vehicle is stolen, there is no model, there is no system from which we can get the current updates of the vehicle, that it is still stolen or recovered, and if it is recovered, then when and where it is recovered. the available system is not secure, because most of the times a theft vehicle is using in some criminal activities like human trafficking, drug dealing, weapon dealing, like these. So there may be some risk because the driver may carry the weapons with them. So it may be risky for toll authorities to stop the vehicle at the toll plazas with the available system. The existing system is not able to detect the vehicle whose speed is more than the limited speed. So these are some limitations from this research. And the methodology we will use for proposing the system is, first we will collect the data, which is theft and non-theft vehicle data. These kind of data will include each and every information about the owner and the vehicle. After that, model will be designed with some technologies using RFID, ANPR, OTP, GSM, and then the model will be implemented and analyzed. We will analyze the proposed model. So elements of proposed model are RFID, which is also called as FASTag in India. The RFID is a radio frequency identification technology where two systems are work, RFID tag and RFID reader. The RFID tag has been mounted on the windshield of the vehicle, and RFID reader is on toll plaza. Central server, which will the data regarding to vehicle and the owner, and each and every data about toll plaza will be stored at the central server. ANPR, as I discussed before, that ANPR technology will where we will capture the number plate image from the camera, and then we will get to know the detail of the vehicle and the owner. GSM will be helpful to communicate between mobile and computer, and will be useful for sending and receiving messages, and obviously buzzer at last. So the working mechanism of the proposed system is, whenever a vehicle is theft, first of all, the system will check that the FIR of the vehicle has been lodged. If the FIR is lodged, then the tag will be shown as blacklisted. Then the system do not allow the vehicle to cross the gate. But if the tag is not available there, then our ANPR system will take place. The system will check the number plate after capturing the image of the same. Like if there is a number plate with the 123 number, the system will check the number plate, and the message, OTP message, will be sent to the owner of the registered mobile number with number plate 123. So if the driver is able to provide the OTP, then only the authorities allow the vehicle to cross the gate. But if it is not, then one more step will be included to check the ID manually, because each and every information is stored in the system. Then the authority will check the ID manually, and if ID is valid, then only the system, the authorities allow the vehicle to cross the gate. And the same situations will be done if the FIR is not lodged of the theft vehicle. So the results are, the system will be built with central server connected with camera, RFID technology, sensors, and GSM module. Firstly, we will insert training database of theft and non-theft vehicle. One by one, the database will be inserted. Like first of all, we will insert theft vehicle with RFID details, then theft vehicle data without RFID but with original number plate, then theft vehicle without RFID and fake number plate, and then the data of non-theft vehicle will be inserted. After checking the data according to the proposed system, the system will be recognized that the vehicle is theft or not. If the vehicle is theft, the GSM module will send the message regarding to this to the vehicle owner and the nearby police station. And if the vehicle is not theft, then they allow the vehicle to cross the gate. So the conclusion is, the system will be very efficient, cost effective, and will reduce the vehicle theft cases, and might be increase the vehicle detection in India. And also the RFID technology will make the traffic smoother, efficient. The obstacles of this study could be is to collect the actual stolen vehicle database from regional transport office and police department, and also the system could not work properly in low network areas. Also, in future scope, we can add a weapon detection system as airports to make the system more less risky. So these are some references of the research I have included. And thank you, sir, and our founder, Dr. Ashok Gupta, sir. Any question and answer, please?
Okay, thank you so much. And okay, I think we running out of time, but yeah, I would like to suggest maybe you can put like some results here, because actually like the methodology and everything you explain in detail, which is good, but what is missing is that the results, like the real results from this work. Like,
Okay.
can you explain a little bit on the results for us to hear?
Resources like what do you mean by resources?
The results of your work.
Resources of my work is
Experimental results, yeah.
what from where I have collected the data.
Ah, I see.
No, Kamlesh, she is asking result of the project.
Resources.
Results, not resources.
Results, experimental results, like the
Experimental
number,
results. Yeah. Like
accuracy or error or like false positive.
The system is not like implemented yet, but in some in few months we are going to implement the system, because it is the first stage of my research. So we are going to implement this with the combination of these elements, and after that only we can go for the results. And obviously we will validate the results and compare them from the previous researchers.
Okay, yeah, that would be great. Yeah. Okay, thank you so much. Yeah.
Thank you so much, ma'am. Thank you so much.
Thank you for your presentation, and also I want to sincerely thank all of our authors for their excellent presentation and contribution in this session, and all of our participants for being part of this international conference. I hope this session was very informative. All the presenters will be getting their digital certificates through email within 2 working days. For the further, all the papers have already been forwarded to the Springer. The publication will be live within 5 to 6 months. Kindly cooperate with the team of World S for 2021. Sharing this session, and I'm just going to share my screen very quickly. So this certificate is a token of our appreciation for the share on behalf of Team World S4 2021 and Global Knowledge Research Foundation. Thank you for your valuable. I'd like to kind of request everyone to turn on their cameras quickly for a quick snapshot of the virtual conference.
Yes, our session chair, do you want to say something with the presenter? Just
yes,
few words.
Yeah, so I would like to thank you to all speakers and everyone here, all the participants. So thank you very much for your contribution and your attendance here, and I'm very happy to see all of you here today. Yeah, I think we should have a group photo, right?
Yes, thank
Turn
you.
on camera and have some group photo. Yeah.
Yes. I request everyone to please turn on their camera. Now it is a virtual world from last 1.5 years almost. Yes, hello, Mr. Libero. How are you?
The mic is muted, I think.
Yes.
I try to adjust my terminal so that audio and video are okay. You are hearing my voice?
Yes.
Okay. I will not have a presentation for now.
Okay. Nahid, have you taken photograph?
Yeah, I've taken the photograph, yes.
Okay, thank you everyone, and hope to see you everyone in physical conference might be next year. Thank you.
Thank you. Take care, everyone.
Thank you. Have a good day.
Yeah.
Bye-bye.
Bye-bye.
Thank you all. Have a good day.
Thank you, everyone. Thank you so much.